Okay, hello dear friends. So we will do some mathematics. So this one is about sequence and series. And it's a chapter review. Review number 1 for the sequence 2, 6, 12, 20, 30, 42, 65. Ding, 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 ding. Write the next two terms telling what pattern you used and draw the graph of the first sixth term of the series. Write an equation expressing Tn in term of n. Use the equation to calculate T700. Okay, let's do it one by one. So first I will write down what number we are talking about. So we have this number, start with number 2, 6, 12, 20, 30, 42, 56. So when I first see this problem, I was thinking of arithmetic series or geometric series. So I was trying to see, and then I see the difference between these two is 4, between these two is 6, between these two is 8, between 20, 30 is 10, between 30, 42 is 12, between 42, 56 is 14, and I was just thinking, getting on with it, and just cannot get out. And then I changed another way. Actually, I saw the answer of it. And it took me 1 hour, 2 hours trying to figure out the pattern. And I just could not, because I went to the wrong track. And now you see the answer of this and becomes so much easier. The first one is 1 times 2, and 2 times 3, 3 times 4, 4 times 5, 5 times 6, 6 times 7, 7 times 8, and then the next one will be 8 times 9, and then the next one will be 9 times 10, right? And with such a way of patterning it, so the term 1 is 1 times 2. Term 2 is 2 times 3. We get. So term 1, this one is the term number. This is 1 plus the term number. So we can conclude Tn equal to terms n times n plus 1. Now let's try it to prove if this is right. 1, 2, 3, 4, 5, 6, 7. Okay, the seventh term. 1, 2, 3, 4, 5, 6, 7. Seventh term, if we write in this formula, should be T7. T7 should be 7 times 8, should be 56, which is right. So our formula is right. So the formula is Tn equal to n times n plus 1. Do not overthink. Sometimes when you think not in the right direction, stop and try to think things in another way. You can solve the problem easier. Draw a graph of the sixth term in the series. Okay. So we start from, I will use a ruler to do this. This is supposed to be using a ruler. My ruler is not so good. So we use this as 2, This is 0, 2, and 6. 6, 2, 6. Okay, I will do it again. This is a broken ruler, but it's more fun to use a broken ruler, right? Who made it broken? Okay, this way we can see better. So we start from 0, and the first one is number 2. I use every centimeter as 2. 2, 6. The next one is 12, 12, 20, 20, 30, 42, 42, and 56 will be 27 here. So 56. Did you see it grows? There's not a certain proportion. It does not grow in the same distance, and it does not grow the same proportion. So this is neither arithmetic series nor geometric series. And with this clear, we keep on looking at the problem. Now write an equation. We have written the equation. And write the following two terms. The following two terms. We have already got 56, and then 72, and then 90. So this is the next two terms. And use the equation to calculate T700. So this is the term, a formula. T700 equal to n means 700 times 700 plus 1. So 700 times 701. 7 times 7 is 7, 7 7 49, 20 at the back. So 49700. This is the answer for this problem. Okay? Thank you very much. Now we come to question number 2. Okay, I increase a little bit of the, magnify a little bit. Answer the following question. Is the sequence in problem R1, review 1, arithmetic, geometric, or neither? So it does not increase at the same, this difference, it does not increase with the same rate. So it's neither arithmetic nor geometric. It's just a gibberish or n'importe quoi or freestyle, series. Find T56 for the arithmetic sequence with T1 equal to 237 and common difference -7. Okay, so we want to, this is another problem. So we want to find term 56, and what is given is that T1 equal to 237, right? Yes. And the common difference, D difference, is -7, right? T1 equal to the starting number A plus n minus 1 times D difference. Now we know, Tn, this is a formula. And we know T1 is 237 37 equal to a plus 1 minus 1 plus times d is 0. So 0 times negative 7. So we know a equal 237, right? So T1 is 237 and Tn equal to a plus n minus 1 times d, still the same formula, and T56 equal to a 237 plus n is 56. I put it a little bit smaller so that you can see the whole picture. 56 minus 1 times negative 7. So 237 plus, and this becomes negative 55 times 7. 55 times 7, 5735，5735，385。So 237 minus 385, 237, 841. So the answer is negative 148. Okay, we got it right again. Now keep on. Question number C. An arithmetic sequence has T1 equal to 164 and common difference negative 9. If Tn equal to negative 484, find n. Okay, so we got another problem here. So first we got T1 equal to 164, and we know the common difference d is negative 9, and we know Tn is negative 484. Now we look for n equal to how many? We know the formula Tn equal to a plus n minus 1 times d, right? T1 equal to a plus 0, 1 minus 1 is 0, so d is no. So we do not need to calculate this. 0 times d. So T1 equal to 164. So T1 equal to 164, which is given. So A equal to 164. Now we know the formula, we can put it in practice. Tn equal to A plus n minus 1 times d. Tn we know negative 484. There's nothing complicated. You just need to do the calculation. 164 plus n minus 1, n times d is negative 9, and negative plus d is negative plus 9, right? So move this one to this side, negative 484, and this one is minus 173, right? This together is 173 equal to negative 9 n 7 5 4加4的 6 7 6 5 7 negative 6 5 7 equal to negative 9, and this is pure arithmetic calculation. So negative negative get out. 7 9 63 3 7 21 so n equal to 7 9 63 7 9 63 3 9 27 so n equal to 73. That is the answer to this problem. Okay, the next one, D. Okay, D. Find T31 for the geometric sequence with T1 equal to 17 and common ratio 1.2. Okay, I always like to use my formula. First, we write down the given. Given is to find T31 is what we want to figure out. This is a variable. And it's given T1 equal to 17. And common ratio, always the same pace of growing, is 1.2. We know Tn equal to the starting number a times r to the rate of to the power of n many times. So t minus 1. So t when t1 equal to a to the power of r 1 minus 1. So it's r to the power of 0. Anything to the power of 0 is 1. So T1 is equal to A. And we know T1 is 17, which is given 17 equal to A. So we get to know A equal to 17. Now we need to figure out T, and R is given is 1.2. So T31 equal to A 17 times R 1.2 to the power of n minus 1, 30. 17 times 1.2 times, I will use my my decimal to do this calculation. Now I am in decimal. I will close other window so that you will not see anything else. You will not see a gazillion. Okay. Okay. Now we take. Okay. I have did the calculation, and it's. I forgot to videotape it, so you will not see I clumsy putting in the number. But the result, as we can see, is pretty clear. 4,035.397. That is the result. So term 31 is this. Okay, now we come to see question number E. A geometric sequence has T1 equal to 11 and common ratio 3. If Tn equal to 24057, find n. Okay, so let's copy the problem first. So we get to know that T1 is 11 T1 is 11. This is given. And the common ratio R equal to 3. So first, to begin with, and Tn equal to 24057, right? Yes, and look for n equal to, sorry, totally out of the range. T equal T1 is 11, R is 3, Tn is this, and n is how many? So to begin with, we always write down the formula. Tn equal to A times the initial number times rate n minus 1. I like to write it this way. So T1 equal to A times 1. T1 equals to A. T1 equal to 11. So A equal to 11. So we got this number settled and we know 3. Everything becomes so simple. Don't you agree? So Tn equal to A times R to the power of n minus 1. I always, this one does not need to have this parenthesis. Okay, Tn equal to 24057 equal to A is 11, R times 3 to the power of n minus 1. What do we do now? So we first calculate this part. 24057除以 11, 222, 111, 95, 8, 88, 77, 7. So 2187 equal to 3 to the power of n minus 3. So we can write it this way: 2187 equal to 3 to the power of n divided by 3, right? So 3 to the power of n equal to 2187 times 3. 37 21 38 24 26 13得3 1得5 23得6 So 6561. 3 to the power of n equal to 6561. So n, we can use logarithm to figure it out, or we can use our all magic decimal. So so what do we do here? So log, you cannot see it clearly. Okay, we find log and the base, log base 3, and the number is 656561 is 8. So to the power of 8, 3 to the power of 8 is 6561. And the answer is 8. This is the answer. So decimal has given us the answer, and we figure out n is 8. 3 to the power of 8 is this number, so it's in the nth term, the 8th term. And the 8th term, we got this number. Okay, that is another one. Now, let's see. Review number 30. Review number 3. Answer the following question. Insert 5 arithmetic means between 17 and 63. 17 and 63. Gosh, why I always make this paper this way. So let's take a look. We have 17, Jing, 1, 2, 3, 4, 5, and then 63. So we need to put this number, and it's have the same because it's arithmetic mean, so it needs to be growing at the same pace. So we have 5 numbers divided here, and what we can do is that we see the difference here. So this number, there are 5 numbers here, right? So we say this is number 1, number 2, number 1, number 2, the number 3, number 4, number 5, number 6, number 7, right? And the first number is 17, and this number will be 17 plus D, 17 plus 2D, 17 plus 3D, 17 plus 4D, 17 plus 5D, and until here. And this will be 17 plus 6D. What do we know? T1, the first term is 17. And the last term, 1, 2, 3, 4, 5, 6, 7. Term 7 is 63. You add 5 number inside, and beginning number and the end number all included should be 7 numbers, right? So T7 is 63. And we want to know the distance between them. So we can use our formula Tn equal to A plus n minus 1 times the difference. T1 equal to A plus 1 minus 1 times D is 0. So T1 is 17. So A equal to 17, right? Now we can put in this formula. T1 is 17. So T7 is A plus 7 minus 1 times D. 7th term is 63 equal to 17. A equals 17 plus 6D. 7 minus 1 is 6. And this one we need to do some calculation. 46 equal to 6D, and D equal to 46 over 6 equal to 23 over 3. So it's also 7 and 2 over 3. Uh-oh, it's out of the red. Why it's so dark? So we will add in the number. So the first one is 17, and the second number is 17 plus this number is 24 2/3. And then plus 7, we always have this common difference here. Let me write it down. 7 2/3. 7加4等于11 32又1/3，再加7加3加2等于40，这个是47又2/3，这个是7加7 27 14 14 15 55又1/3， and this plus this plus 7. Yeah, exactly. So we get the number, the common difference, and you just need to add up the number. Okay, question B, insert 3 geometric means between 4 and 100 if complex numbers are allowed. Okay, so first we need to figure out, or we need to write it down. The first number, T1, the first term, T1 equal to 4, and T, I will draw it, 4. We need to add 3 insert insert 3 geometric terms. 1, 2, 3. Insert 3 geometric terms until it reach 100. So this one, they are not the same distance, they are not the same difference, but they are the same rate. So the T1 is 4, 1, 2, 3, 4, 5. Totally we have 5 terms. 3 in the middle to add in, 2 at the 2 extremity to enclose this number series. So T5, 1, 2, 3, 4, 5 equal to 100. Now, this number should be 4 times a rate. Four times a rate to the 2, 4 times a rate to the 3rd power, and this is 4 times r to the 0 power, 4 times r to the 4th power. Okay, and we know the Tn, we know the formula. Tn equal to a times r to the power of n minus 1, and T1 equal to a to the power of r, 1 to the power of 0, which is 1. T1 equal to a equal to 4, T1 equal to 4, so we get to know a equal to 4. And T5 equal to a to the power of 5 minus 1, right? So T5 is 100, and a is 4 to the power of r to the power of 4. Divided by 4 on the both sides, 25 equal to r to the power of 4. So r to the power of 2 equal to positive negative 5. Okay, so r equal to positive, negative, square root of 5, and r equal to positive, negative, square root of 5, I. So that is the answer. So what do we put in? 1, 2, 3, 4. 4 result. So we can put in this one, 4 to the power of 5, square root 5, 20, 20 square root of 5, and 100. For negative 20, and this 20 is never changed. At this situation, negative 20 square root of 5, or negative, or 4 square root of 5i, negative 20, and 20 square root of 5i, negative 4 square root of 5i, negative 20, and negative 20 square root of 5i. It looks complicated, but it's actually quite symmetric. Ding, 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 good, 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 bad, good, bad, bad, good, bad, good, bad, good. Oh, I should not say bad, bad, bad. I should not say good, bad, but you know, it's all that symmetrical, and there is a symmetrical axis in the middle, on the left, on the right. You know what I'm talking about. Okay, hello dear friends. Here we have another problem. What is the geometric mean of 25 and 100? Two possible answers. Why two possible answers? Let's see. And geometric mean, only two numbers. Only there is no adding in another number or something. So it's much easier. So we know the first number is 25. Give me a drum roll. 25. 25. And the second number is 100. Drum roll. Come out. Okay, two numbers. What is geometric mean? Geometric mean means two number time together and then square it to the power of 2. If three numbers will be cubed, I guess. I didn't learn that yet. Geometric mean, yeah, it kind of makes sense, right? Okay, so it's square root of 2,500, so it is positive and negative 50. Make sense? Because positive 50 times positive 50 equal to 2,500, which is the two numbers timed together. Negative 50 times negative 50 equal to 负负得正 2,500. It is still the same number. So the answer is positive and negative 50. Give me a applaud. Hai Ying, I love you. You are my best teacher. Actually, I learned everything from this textbook and Khan Academy. I love you, I really do. Okay, hello dear friends. Review number 4. Do the following. Evaluate a sigma notation. Delta. A sigma. Sigma k equal to k factorial. K factorial. K equal to 1 until 5. Okay, now let's do it. I will copy this. It's sigma notation. When you do not know it, it's kind of confusing. But when we understand all the sigma notation, do I need to do this? Not so important, right? K equal to 1, k factorial, k 的介乘. So it means the first one is k equal to 1 until k1, k2, k3, k4, k5. Until this number is matching with this number, starting from k1. Okay, so we can use as a summation formula. Summation is easy because we know 5. So 1 factorial times plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial. Sorry. So 1, 2, 3, 4. This factorial. I move a little bit of my camera. So 1 times 1 is 1 plus 2 times 1 is 2 plus 3 to 1 is 6 plus. So actually, you can start to figure out 2 factorial and 3 factorial is 2 factorial times 3 and 4 factorial is 4 times 3 factorial. 4, 6, 24再加上5乘以24 120. So this is 30, 33, 33 and 153 equal to 153, and that is it. And write using sigma notation. 1/4, 1/8, 16/1, 32/1加64/1. So now we first write until infinity, right? This is not finite, it's infinite. So we first copy it. 1/4 plus 1/5, 1/16, 1/32, plus what? So now we see what is this. T1 equal to 1/4. And we know the ratio R equal to 1/2. So Tn equal to times right? So equal to 1/4 times so we can write like this. So when n t equals 1, the first term is 1/4. The second term is 1/8. The third term, yeah, it is right. You can also write as 2 to the power of negative n plus 1. I personally do not like it this way, but it is also right. So the sigma notation n equal to 1, and it goes to infinity, and the formula of it is 2 to the power of n plus 1. And that is it. That is my glorious sigma notation. Sigma notation. Today I didn't do a good job in drawing it, but that is it. I hope you like it. If you don't, just don't. So what? I love you, I really do.